Hello, my Algebra 2 students. You are going to notice that for the day 2 notes, it's another page that's just blank in your packet. So we are taking our own notes today, and what we're focusing on are forms of a line. Now, 2 pages should be good if you have relatively small handwriting. If you have really big handwriting, you might need an extra page, and in that case, just tuck it into your note packet. Right? So the 2 forms of a line that you should definitely know the first one, and I think last year in geometry you learned the second one, are called the slope-intercept form of a line. And then point-slope form. The good thing is the names pretty much tell you everything you need to know. So when we think of slope-intercept, the slope we know is m. So for both of them, we're talking about the m value, right? For the intercept, we think y-intercept, that's the b. So this is the one that is y equals mx plus b, which I think is what most people think of when they think of the equation of a line, right? As for point-slope form, this is where you have to know just any old point on the line. It doesn't have to be the y-intercept. And so in that case, we would call that point x1, y1. Right? For that equation, it looks like y minus, oops, let me fix that, y minus y1, and then equals m times x minus x1. For each of these, you keep the plain old x and y, and you plug in for the other variables. So you guys know that when you're used to seeing an equation here, you would be plugging in for the m and the b over here. Over here, you'd plug in the coordinate points of some point you know is on the line for x1, y1, and then you'd plug in for m, the slope itself. Right? So the only difference between them, I mean, you can represent any line in both formats, but the difference between them is that when you go to graph it, if we draw ourselves like a mini little sketch here, if I give you a line in y equals mx plus b form, we start by plotting the y-intercept, which would be whatever that b value is, and then we'd count out the slope to say, okay, go up and over however much, right? And then that would give us another point on the line, and we could connect, right? Whereas in terms of point-slope form, over with this, you would plot whatever point you're being given first, and that point could be anywhere. So it could be over here in quadrant 1, 2, 3, 4, wherever. So let's say it's over here. So this would be my x1, y1. And then from that point, we would count up and over whatever the slope is, or down and over, it depends on the question. And then you'd be able to go from there, okay? So it just depends on where you're starting it. Sometimes if we take lines in this format and solve them for mx plus b, they get messy, which is why occasionally the point-slope form actually works a little bit better. So I'm going to tell you right now, if you can fight the urge to always put everything back into slope-intercept form, it will sometimes serve you well. Right? So we're going to run through some examples. The very first one, I'm going to give you a function. So if I give you f of x equals 3x plus 5, I want you to find a couple of things. So first thing I want you to find is the y-intercept. Right? And then the second thing is I want you to find the average rate of change. All right. Now, because I'm well aware that the first one is given to you in slope-intercept form, you don't really have to do a big show of finding the y-intercept. But in general, for any function, to find the y-intercept, we set x equal to 0. So the reason it comes out is just this value over here is that you would technically plug in 0 here, which would wipe this out completely, and you'd end up with 5. So our point 0.5 should make sense based on how you find any y-intercept. As for the average rate of change, right? Typically, I would have to give you an interval. So if I said like over, 2 is less than or equal to x, less than or equal to 5, just as a reminder, you would do f of 5 minus f of 2 all over 5 minus 2. But what you should know right now, because that's a linear function, it's going to come out equivalent to the slope. Right? And if you actually look, f of 5, if we plug 5 in here, that would be 20. If we plug a 2 in here, that would be 11. And then we would end up with 9 over 3 or 3, which matches the slope right there. Second example, let's actually do one where we have to do some calculating here. Right? So I'm going to tell you, and if you don't want to write all the words down, you can summarize or abbreviate on your own, but I'm going to write it all out. A line has a slope of 5 and passes through the point -2, 8. What I want you to be able to do is write the equation of the line in ... two forms. First one is actually going to be the point slope form because it's already geared up for that format. Second one would be to write it in slope intercept form. All right. When I say it's already geared up for point slope form, we're literally handing you a point. So this would be your x1, y1, handing you a slope. There's your m. All you'd have to do is just plug right in. Right? So it's, keep doing that, y equals, I mean to say y minus. So I want you to think of it like this, that it's y minus, and then you fill in the blank, and then equals, fill in the blank, x minus, fill in the blank there. So there's the 3 places we're plugging on in, right? The slope goes in as that coefficient in front of the parentheses, and then the point. The x goes on the inside with the x here, so -2. The y comes over here with the 8. Other than changing it to maybe plus a positive, that's your answer if it says point slope form. Don't do a darn thing more than that. When we now say slope intercept form, now let's just clean this up. So to get from here to here, when I mean by clean it up, let's distribute. So distribute the 5 on through. So this would be 5x plus 10, and then get it solved for y. So we can add the 8 over, and we would get 5x plus 18. Right? So both of those, same line, just 2 different ways to see the answer. Right? That's it. Right? The next one, I hope you got your calculator sitting next to you. Yeah, it's math. You should. So on your graphing calculator, that's what I mean by GC. GC could mean a lot of things this year. We got Google Classroom, but on our graphing calculator. So if you need to elaborate, go ahead. I want you to type in y1 equals 3x plus 2, and that y2 is equal to 3x minus 4. Mm-hmm. So I'll grab my calculator here. First thing, 3x plus 2. Second thing, 3x minus 4. So zoom 6, because who knows where you left your calculator screen last. All right, so my blue, that's my y1. And then my red, that's my y2. So things that should make sense. Y-intercept at 2, counting up 3 over 1. So we've got that positive slant up to the right. And then the second one, starting at -4, and then that same slant. So when we have that same slant, if you will, think back to your geometry brains right here. We know that the lines should be parallel to one another, all right? So there's just a quick way to kind of see that when we have equal slopes, what we should end up with are parallel lines. So all of those coordinate proofs you did last year, you used that reasoning throughout it, which actually, now that I'm thinking about it, I'm not sure how much of that you did in geometry, given the kookiness of last year, but you should still know that concept, that if the slopes are equal, the lines are going to be parallel. So that's pretty key right there. So then what I want you to think of is, what would give you perpendicular lines? This is a special relationship here, and that's if you take the slopes, flip it over, and negate it. So that second rule is if you have negative reciprocal slopes, that will give you perpendicular lines. So I don't really think I need to explain equal slopes much further, but an example of negative reciprocal slopes is if one slope is 2, then the perpendicular slope would be, if I flip and negate, would be negative 1/2. So that's an example of negative reciprocal slopes. All right, I'm out of space on this page. I'm going to hop on over to the next page for example 4 here. So when we flip on over, let's do a little bit more with just remembering how to write the equations given those different scenarios. Right. Oops, let me slide back this way. So example 4, I want you to be able to write the equation of the line parallel. So I'm going to use my little notation here. Parallel to y equals 3/2 x plus 7. That passes through the point 6, negative 8. Just like last time, I want to see it in point slope form, and then part B in slope intercept form. If you need a second to think, pause the video, try it, and then unpause. Otherwise, what my hopes are is that you would look at this and say, all right, if I need the line to be parallel, I need to keep the slopes the same. So that tells me my M value right there. Here's my X1, here's my Y1. So when I go to write the equation, that's what I'm plugging in. So it would be Y minus something, and then equals something times X minus, here we go. All right. So let's plug in. Here goes negative 8. The slope comes up front. The 6 goes in back. I would ask that you make it a little prettier than that by just flipping this to plus a positive. Otherwise, that's it for the first part. Second part, let's distribute. So we're going to distribute that 3/2 through. So we get 3/2 x, and then 3/2 times 6. Keep in mind, if you want to do it without a calculator, 6 times 3 would be 18, and then divide by 2. So that'll give you 9. And then subtract the 8 on over. So we'd end up with 3/2 x and then minus 17. And now you can always check these answers. Graph this guy, compare them. Does it go through the point you think it should? Are they actually parallel? Those are easy ways to check. All right, for example 5, this time you got to do a little bit more work. And so determine the equation of the line that passes through the points 5, negative 2, and 24. So determine the equation of the line that passes through the points 5, negative 2, and 24. In this case, I always want you thinking, regardless of which equation you use, you would still need to figure out what's the slope for either one, and then you either need to know the y-intercept or have a point to plug in. So in this case, we have 2 points to work with, but we don't have the slope, so you have to start by calculating that first. So slope, change in y over change in x. 4 minus negative 2, and then over 20 minus 5. That flips, so we get 6 over 15, and that'll reduce nicely. And if you're not sure how to reduce it, grab your calculator. Don't forget, you guys, that you have stuff like 6 divided by 15, and then you can math frac it. Because I'd rather see 2/5 than 0.4 as your slope here. All right, so here's our slope value. All right, now start with what is obvious. You have a point, 2 of them, and you have a slope. So the point slope form makes sense to start with here. It doesn't matter which point you use. So if I use the first point, then my answer would look like y minus a negative 2, which really means plus 2, and then equals 2/5, and then x minus 5. Or you could have y minus 4 if you use the second point. You'd still have the 2/5, and then this would be x minus 20. The key is that both of these are equations to the same line. So technically, you could have an infinite number of answers for a point-slope form. The one advantage to slope-intercept form is there is simply one answer because there's only one y-intercept, right? So either one, if we now say, let's write this in slope-intercept form, either one that you clean up should get you where you need to be. So if we distribute that 2/5, we'd get 2/5 x. 2/5 of 5 is going to be just 2. And then we can subtract that 2 over. That would land at y equals 2/5 x, and then minus 4. You can kind of see if I did this over here, 2/5 times 20. So you can do it on your calculator, or you can think of it as 2 times 20, which would be 40, divided by 5. There's where the 8 comes from, right? So you would end up with 2/5 x, and then minus 8. And then you'd have to add the 4 over. That would give you the same answer right there. All right, we only have 1 or 2 more examples, and we might even save one for class. But example 6, this one, actually, I think this is our last example that we need to cover for the day. It's a little bit of a geo throwback here as well. So you're seeing a lot of like Algebra 1 and geometry in today's notes. All right, write the equation of the perpendicular bisector of segment AB. Right. So last year we would have constructed the perpendicular bisector. We might have used it in a proof as well, right? But now we should be able to easily write the equation. So I'm going to give you point A is the point 2, 9. Point B is the point 8, 7. If you have graph paper rolling around, sure, you could graph it and take a look at it. Otherwise, think about what I'm even asking you to do. So when we think about these 2 points, we sort of just sketch a general idea. You know, let's say here's 2, 9 is A. B is somewhere down here at 8 and a little lower, 7. So something like this. Perpendicular, we know that piece of it. Bisector. Bisector means we're cutting it into 2 equal parts. So it should go right through the middle and then at a 90-degree angle. So going right through the middle means it has to go through the midpoint. Hopefully some of these formulas have still stuck with you. It's the idea that you have to average the x's, average the y's to be able to calculate the midpoint algebraically. So average the x's. So that's 2 and 8. So 2 plus 8 over 2. Averaging the y's, that's the 9 and the 7. This is going to give me 10 over 2. This gives us 16 over 2, which should then produce 5 and then 8. Should make sense. 8 is right between 9 and 7. 5 halfway between 2 and 8 for the x's there. All right. So there's the midpoint. So here's the point that we need to use. Then for the perpendicular, we need to know about the slope. So we have to first calculate the slope of AB before we can do the perpendicular slope of it. So change in y over change in x. Do you have to write that each time? No. All right. I just want to remind you what we're doing. So 7 minus 9, and then over 8 minus 2. It looks like a negative 2, but that's just me touching my paper. So let me just clear that up to make sure that nobody thinks that's a negative 2 there. All right. This would give me negative 2, and then over 6, so negative 1/3. So if the slope of AB is negative 1/3, then the perpendicular slope, here's where that negative reciprocal comes in. Flip it over, negate it, would be positive 3. All right, here's the 2 things we need. We need a point on the line, so we found that point. We need the slope, which would be the slant of this guy right here. And so let's plug it in to write the equation. So since we have a point and a slope, to me, it would make the most sense to use the point slope formula. So what I would like is for you guys to finish this right here, and this is going to be your post video question. Tell me what the equation of the line is in point slope form. All right. Thanks for watching, guys. Go answer that question right now.